We look around our modern cities and assume we are the absolute masters of this planet. We walk the earth with the quiet confidence of a species that has conquered every environment and bent nature to our will. Thousands of years ago, the pharaohs ordered the construction of stone pyramids to defy time itself. It was a massive architectural attempt to leave a permanent scar on the landscape. From stacking stones, we accelerated our technology until we broke free of Earth's gravity entirely. We launched humans toward the stars and walked on the moon, expanding our domain into the vacuum of space. We also developed a terrifying capacity for self-destruction. By splitting the atom, we built weapons capable of leveling entire cities in a flash of blinding light, proving we can erase civilizations as quickly as we built them. To understand our actual footprint, we have to compress all 4.5 billion years of Earth's history into a single 24-hour clock. Let's imagine the Earth is born at the exact stroke of midnight. Fast forward through the boiling oceans and the dinosaur empires, and you finally arrive at humanity. Every pyramid, every moon landing, and every war you have ever studied takes place in the final 1/10 of a second before the next midnight. That tiny pulse of time is our only footprint on a planet that spent the previous 23 hours and 59 minutes in constant, violent upheaval. Look at Earth at the beginning of that clock. You won't find a blue marble. The surface was a churning ocean of boiling magma, suffocating beneath a heavy, toxic atmosphere of sulfur and carbon dioxide. Then, a Mars-sized planet named Theia hurtled out of the dark and slammed directly into our young world. The collision vaporized the outer layers of both planets into superheated pass, nearly shattering Earth entirely. Trillions of tons of molten rock were flung into orbit, forming a massive fiery ring. Over thousands of years, gravity pulled those fragments together. They coalesced and fused in the vacuum of space to form our moon. That planetary impact created the conditions we rely on today. The moon's gravity acts as a massive anchor, stabilizing Earth's axial tilt and preventing the climate chaos that would otherwise make complex life impossible. Fast forward to the primordial oceans, where a single-celled organism called cyanobacteria developed a biological machine, photosynthesis. They began using chlorophyll to absorb sunlight and manufacture their own food. But this process produced a massive amount of waste. They pumped billions of tons of oxygen into the water, a gas that was originally a reactive, lethal toxin that destroyed early bacterial life on contact. The oxygen reacted with dissolved iron, turning the oceans into a rusty soup. Once the oceans were saturated, the gas flooded the atmosphere and destroyed the methane blanket that was keeping the planet warm. Without methane, global temperatures plummeted. Massive ice sheets crawled from the poles to the equator, locking the entire planet beneath ice kilometers thick. Earth became a silent, brilliant white sphere drifting through space. Pushed to the brink, life adapted through a desperate act of cooperation. A large cell swallowed a smaller bacterium, but instead of digesting it, they merged. The small cell processed the toxic oxygen into energy for the host, creating the complex eukaryotes that would eventually build every animal and plant on Earth. Millions of years later, the planet attempted to wipe the slate clean again. Massive magma eruptions in Siberia ignited underground coal deposits, suffocating the globe in toxic gas and extreme heat. 96% of all marine species vanished. This slaughter left the world's ecosystems empty. Into that void stepped the dinosaurs, growing into massive sizes to command the planet for the next 160 million years. They evolved into specialized biological machines. Apex predators like the Tyrannosaurus rex wielded jaws equipped with thick, serrated teeth designed to crush bone. For millions of years, they stood at the absolute top of the food chain without natural enemies. That dominance ended on a normal afternoon when a 10-kilometer-wide asteroid plunged from space, piercing the atmosphere at 60 times the speed of sound and striking the shallow waters of the Gulf of Mexico. The impact vaporized billions of tons of rock, igniting global firestorms followed by a pitch-black nuclear winter. The ash blocked the sun and halted photosynthesis, causing the entire global food chain to collapse from the bottom up. As the giant reptiles starved, a few tiny creatures survived beneath the ash. Our mammalian ancestors lived through the deep freeze because they could hide in burrows, generate their own body heat, and nourish their young with breast milk when external food sources vanished. The absolute dominance of the dinosaur empire was severed in an instant when the global food chain collapsed. This total erasure of the old order cleared the path for our mammalian ancestors to finally leave their burrows. With the dinosaurs gone, mammals engaged in an evolutionary sprint, expanding in size and spreading across the newly cleared continents to fill the vacant niches. In East Africa, a cooling climate turned dense rainforests into open savannas. Early primates were pushed out of the safety of the high trees and forced onto the ground, exposed to predators many times faster and stronger than themselves. These vulnerable creatures executed a massive evolutionary gamble. They stood upright on two legs. Standing upright freed their hands to grip and manipulate objects, which forced their brains to expand to handle the mechanics of making tools. In an evolutionary blink, this weak prey harnessed fire and language, allowing them to organize into tribes and eventually conquer every corner of the planet. By unearthing and burning millions of years of sequestered carbon, we are now physically altering the chemical composition of the atmosphere at a planetary scale. We are driving atmospheric changes at speeds that mimic the ancient cyanobacteria or the deep space asteroid, events that previously reshaped the entire global ecosystem. Our legacy will be visible in the Earth's crust as a compressed band of microplastics, chemical synthetics, and radioactive isotopes. This thin, unnatural layer will mark our presence long after our cities have turned to dust. We have leveled mountains and drained the Earth's crust to fuel an industrial machine that is now introducing a dangerous volatility to the global climate. Earth has survived massive space rocks and frozen oceans, and it will survive us. The only real question is whether we will be wise enough to maintain the fragile conditions that keep our species alive, or if we will become just another thin layer of extinct fossils.